In this video, we're going to walk through everything you must know cold for AP Calculus Unit 6, Integration and Accumulation of Change. This is one of the most important units in the course because it introduces integration, which is how we measure total change, not just instantaneous rate of change. If the derivative tells us how fast something is changing in a moment, integrals tell us how much has changed overall. Let's start with the big idea of accumulation. If you're given a rate function, the area between that function and the x-axis represents the accumulated change over an interval. If the rate is above the x-axis, the accumulated change is positive. And if the rate is a really important AP exam idea here is the units. The units of a definite integral are always the units of the rate multiplied by the units of input. For example, if velocity is in meters per second and time is in seconds, the integral is going to give you meters. Some quick vocabulary: partitions of an interval, area under a curve, and net change versus total change. Before we define integrals exactly, we begin by approximating. That's where Riemann sums come in. You need to know four methods for calculating and approximating Riemann sums: a left Riemann sum, a right Riemann sum, a midpoint Riemann sum, and a trapezoidal sum. You may be asked to approximate integrals using graphs, tables, formulas, or a real-world context. You also need to determine where an approximation is an overestimate or underestimate, which depends on whether a function is increasing, decreasing, or its concavity. Additionally, both uniform and non-uniform partitions are fair game on the AP Calc exam. Now we formalize integration. A definite integral is defined as the limit of a Riemann sum. Now, you don't need to memorize this formula, but you do need to understand what it means. A common AP skill is translating between a Riemann sum, summation notation, and definite integral notation. Delta x is the width of each subinterval. Xi is a sample point, and the sum represents adding up the areas of infinitely many tiny rectangles. Now, the Fundamental Theorem of Calculus, Part 1, this is where derivatives and integrals begin to connect. So if g is equal to the integral from a to x of f of t dt, then the derivative of g is equal to the integrand f of x. This means the derivative of an accumulation function is just the original rate function. On the AP exam, you may be asked to differentiate a function by an integral or interpret what that derivative means in context, as well as interpret accumulation functions graphically and contextually. Here's some key ideas that students often miss with interpreting accumulation functions. If g of x is defined as the definite integral from a to x of f of t dt, not only is g prime equal to f of x, but we can understand information from f to describe characteristics of g. For example, g is going to be increasing where f is positive, g is going to be decreasing where f is negative, and g is going to have maxes and mins where f is equal to 0 and changes sign. Now, you'll often use graphs or tables of f to describe the behavior of g, so make sure you're familiar with that. This is a major AP exam skill. Next, we want to talk about properties of definite integrals. Definite integrals follow algebraic rules. You need to know linearity. In other words, you can split up sums and differences of definite integrals, as well as integrals that are multiplied by a constant. Also, reversing the limits on the integral is going to change the sign of your answer. Also, you need to understand the concept of additivity over adjacent integrals. You also need to recognize symmetry. For example, if f is even, the integral from negative a to a is equal to twice the integral from 0 to a. If the function's odd, the integral from negative a to a is 0. Knowing these properties can save you a ton of time on the exam. Now, for the second part of the Fundamental Theorem of Calculus, this tells us how to evaluate definite integrals. If capital F prime is equal to little f, then the definite integral from a to b of little f is equal to capital F of b minus capital F of a. This means you find the antiderivative of little f, plug in the upper and lower limits, and subtract. You must be able to do this both with and without a calculator or Desmos. Now, when it comes to finding antiderivatives in indefinite integrals, there are several different rules and notations that we need to understand. An indefinite integral represents a family of functions whose share a common derivative. In other words, the indefinite integral of f of x is equal to capital F of x, its antiderivative, plus c. Make sure you always include that plus c. A lot of students forget that. Now, some core rules that you'll use are the power rule, the constant multiple rule, and the sum and difference rules. And also make sure you include the plus c for indefinite integrals. You have to remember that not every function has an elementary antiderivative. In other words, you may not be able to find the explicit function that represents the antiderivative. Some functions are defined as definite integrals. Next, we come to integration by substitution. This is basically how we undo the chain rule. You use this when the integrand contains a function and its derivative. For indefinite integrals, you're going to substitute and integrate. Make sure you rewrite your final answer in terms of x, and don't forget the plus c. For definite integrals, you're going to want to change the limits of integration, anti-differentiate, plug in the upper and lower limits in terms of u without back substituting in terms of x. Oftentimes, common mistakes are students leave the indefinite integral in terms of u, or the definite integral, they mix up the limits in terms of x with the limits in terms of u. Now, when it comes to integration, a lot of times you're going to need to use some algebra to evaluate the integral. You may need to use long division when the numerator's degree is greater than or equal to the denominator's degree, or you might need to complete the square to match known integral forms. You'll use this a lot when you have a quadratic expression, particularly in the denominator of a rational expression. If you're in AP Calculus AB, the following are not tested on the AP AB exam, and you can skip to the next chapter in the video. The first topic for BC only is integration by parts, and this basically undoes the product rule. You want to know this formula and know how to use it, how to set it up. There's also partial fractions. You have to know how to decompose rational functions with linear factors. Also, improper integrals. These are integrals with an infinite discontinuity or infinite limits of integration, and you have to know how to use limits in order to evaluate improper integrals. These are the BC only topics. Let's get back to the comprehensive review. One final topic that applies to everybody is being able to select the proper technique for integration. This is a huge skill in Unit 6, so being able to choose the right method is extremely important. You need to be able to recognize when to use basic antiderivative rules, when to use substitution, when you can just use plain old geometry if you have a graph or can easily graph the function, and how to do those different methods of algebraic manipulation. Now, there is no single method that works for every single problem, so make sure you are armed with all these skills. A couple quick AP exam reminders. Always show your integral setup, particularly on Desmos or calculator active questions. You want to include units as well as contextual interpretation when it's required. You want to avoid incorrect chains of equal signs. If it says approximate, make sure you use the wavy equal signs, and then after you calculate your approximation, you can put the equal sign. And finally, make sure you're using parentheses carefully. If you understand these ideas, you're in great shape for Unit 6. Now, before you go, I've created a Unit 6 integration and accumulation of change PDF that summarizes everything we covered in this video. It includes key concepts in student-friendly language, essential formulas and rules, and AP exam reminders and common mistakes. You can download it using the link in the description, and you could use it as a study guide, a review checklist, or a quick reference guide while doing homework and AP exam prep. Now, if this video helped you, make sure to download the PDF, and don't forget to like, subscribe, and share so you don't miss future AP Calculus review videos.